Mr. Bew here. We're going to talk about local noon and time. And first I'm going to look at how the Earth spins around every 24 hours and how the Earth goes around the Sun. The Earth is slightly tilted, so in the summer we tilt towards the Sun, so we get summer. In the winter we tilt away from the Sun, so we get winter. So in winter the days are shorter, and in the summer the days are longer.
The Earth spins on its axis every day and takes a year to travel around the Sun. The UK is in the top half of the Earth in the Northern Hemisphere. In winter, the Northern Hemisphere is tilted away from the Sun. The Earth spins on its axis once every 24 hours. There are a few hours of daylight and the dark nights are long. Seasons change as the Earth continues its journey around the Sun. In summer, the Northern Hemisphere is tilted towards the Sun. In the UK, it is light from early in the morning until late in the evening. The nights are short, summer is here.
So when the Sun is at its highest point, it's your local midday or local noon. So here's the Sun coming up, it'll go up and up and up, then it'll just sort of stop and it'll appear to hang there, then it'll start going down again. When it's at its highest, it is local noon, and when it's at its highest, the Sun is due south of you when you're in the Northern Hemisphere. And then it sets in the west, so it rises in the east and sets in the west. As we saw in the first video, the Earth tilts, which gives us the seasons. During the equinox, apparent to us, the Earth is upright. So the Sun would rise in the east, at local noon it'll be due south, and it will set in the west. So each day the Sun for us will slightly go up or down depending whether we're going from summer to winter. So that will change slightly. But if we set the shadow, so the shadow of the Sun is at its shortest at local midday. If we set it, that'll be okay to navigate from for the next few weeks. But after that, we'd have to reset the shadow to work out where we are. So I'm going to show you a short clip from the History Channel on Vikings, where they discover how to navigate with the shadow of the Sun on the ring. They float the device because it keeps it upright, otherwise the shadow will move in the moving boat. Let's have a look at the clip.
I have something that will change everything. What? What is that? Now just listen. A while back I met someone. A wanderer. He told me it was possible to go west over the open sea using this. It's a sunboard. It needs to sit in water.
This worked on the principle that the Sun is due south each day. So with this, they could sail east or west. So they could sail west to their destination and east back home. So this is the principal tool of the Vikings for their navigation.
Another wanderer. This time is different.
Now tell me, Ragnar, this wanderer of yours, did he ever sail west himself?
Just get some water. Now, this candle is the sun. Every day, the sun rises up into the sky until noon. See how the shadow shortens? At noon, it is at its shortest.
That only tells me how far south they've traveled.
Didn't I just tell you to listen? The day before sailing, you mark a circle around the pointer where the shadow is at its shortest at noon. The next day at sea, you place the board back into the water around noon and watch the shadow. If the shadow only touches the circle,
The course remains true?
yes. And if it passes outside the circle like this,
Then you have drifted, and you must steer further south.
yes. reaches the circle.
Then you are too far south and must steer more to the north.
That's it. Keep the noon shadow on the circle, and your course will be true west.
This will only give you your latitude north and south, because it's got with the angle of the sun. To measure east and west longitude, we will need time. So the best means of measuring time is by the movement of the Earth. The Earth rotates once every 24 hours. So the sun regularly rises and sets every day. Naturally is the best timekeeper throughout the world. So it rises in the east, sets in the west. When it's at its highest, it is due south of you, and that's called local noon. And when it's at its highest, the shadow to the tree here is at its shortest. So when the prime meridian of Greenwich has the sun at its highest point in the sky, all the places along this meridian will have midday or noon. So every place along this meridian, it'll be noon when the sun's at the highest. As the Earth rotates from west to east, these places east of Greenwich will be ahead of Greenwich time, and those to the west will be behind it. The Earth rotates 360 degrees in about 24 hours, which means it rotates 15 degrees in an hour, or 1 degree for every 4 minutes. So every 4 minutes the Earth would have rotated 1 degree. When it's 12 noon at Greenwich, the time at 15 degrees east of Greenwich will be 60 minutes, i.e. 1 hour ahead of Greenwich time, which means 1 p.m. So 15 degrees east of Greenwich, it'll be 1 p.m. At 15 degrees west of Greenwich, the time will be behind Greenwich time by 1 hour. It'll be 11 a.m. So each 15 degrees is a difference of 1 hour. At 180 degrees, the back of the planet, it will be midnight when it's 12 noon at Greenwich. At any place, a watch can be adjusted to read 12 o'clock when the sun's at the highest point in the sky, i.e. when it's midday. So to be able to work out whether you're east or west of Greenwich and your position, you'll need an accurate watch. So this was the story of longitude, where they tried to find a watch that was accurate, that also worked on a vessel that's moving on your sailing ship. And this is the story of longitude, which is another story which we'll tell on another day.